There we go. Okay. Okay. Today's topic, have we got this on so everybody can hear me? There we go. Today's topic is going to be the color of dogs and how we get the color of dogs sometimes. You stay over there. You're out of the picture. We don't want to talk to you. Let's just look at two different colored dogs that we have here. One is primarily black, which would be certainly Lainey, who's in the other room with her puppies. And I would call Sizzle a black dog. She's mostly black. Now, this harlequin color, this and any other, the gray and the merle and the black and all that sort of, they're just sort of a jumble of colors. So if we, for the moment, just divide them into two groups, the jumbled and the black. Now, everybody, all dogs have, everybody, not only dogs, but everybody has two genes, are they called? Two things that determine your color, the dog's color. And with a jumbled dog, why don't we say that they have two yellow, these are DNA type things. We'll call them genes for the moment, okay? Genealogy. And we will say that the black ones have two labels, if you will, that make them black. And these are labels that make them jumbled up colors. The blacks that we have, Lainey, we have Noel. Who else have we got? Sizzle. And the boys, Wilbur and Jasper would all be blacks. And the jumbled ones, we would have Chaos and Scarlet and Gussie over there, Gussie. And let's just try and figure out what happens when we try and breed these kind of dogs. Let's see now. The first dog we try and breed would be blacks to blacks. If we had two blacks, these are two black dogs. Now, when they make the eggs and sperm, which become the baby dogs, each egg gets one of these, and each sperm gets one of those. So, when you make a baby dog, you have one sperm, and that comes like that. And isn't that nice and neat and tidy? And if you're going to do jumbled up dogs, you end up with this arrangement. You end up with more jumbled up dogs. Okay? That's if they're purely bred. Now, what happens if you breed one of the black dogs to a jumbled dog? Okay? Now, when they make the egg and sperm, that splits and this splits. So that when the baby dog is made, you have an egg and a sperm, and you have this kind of a combination. So what color are these dogs? Well, this color is black, and this color is jumbled, but the color, when this happens, one of these colors becomes, one of these labels, if you will, becomes dominant over the other one. So that if you bred this type dog to this type dog, you would get this situation where the puppies would look black because their labels, the black label would take over from the spotted label. Okay? So these dogs, although they have one jumbled label and one black label, they would look black. Okay, so what happens when we start to play with these? If we have a puppy from that litter over here and a puppy from a similar litter over here, what happens if we breed these two dogs? Well, we could have this and this combination. We could have this and this combination, or we could have these two combinations. So in other words, the puppies in a litter bred from these two pups could have both black dogs and jumble dogs. Now let's see if we can demonstrate that just a little bit better. Okay, we'll put some of these all together here. Okay, the first combination we could have, we have one, this is mom, we'll say this is mommy over here. One egg from mommy and one sperm from daddy. We could have that. We could also have this, and we could also have this. Okay? So that in a litter of dogs that are bred with varying parents like this, they would have predominantly black puppies, because that one would look black. But it would have one jumble, one pure black, and one that looked black. And that can get very, very confusing if you're not already confused. Let's say we take a puppy. We'll start at the let's start at the top. We'll make the first baby this, and then we'll go on from there. Okay? Let's say we have, this is a female dog, and we have a male dog. Now when we start bringing one from each side, we can have that kind of thing, and we can have that kind of thing. So although you had a mother, or whatever, this was whatever, you could have one pup that is pure jumble, and the other one would look black. So sometimes you can tell what the parents were because of what kind of puppies they have. But let's look at, that was Gussie. Gussie is one of these, and she was bred to Wilbur, one of these. Now, we don't know whether, she was this color. She has to be, because that's what she looks like. We don't know whether he was pure black or a hidden black. He could be either one. He could be either of these. Either of those. So let's see what happens when we have this kind of combination between these parents. You have one, you could have that kind of dog, and you could have that kind of dog. So, like half your litter would look black, and the other half would be, and that's kind of what you got over there. You've got 3 and 6, but you've got a jumble. You got some blacks, and you got some jumble color. Let's make it more complicated here now. How are we going to make it more complicated? When they describe this in school, they start with what's known as a Mendel Square. This kind of thing, where they put the mother colors over here and the father colors over here, and they figure this goes that way, and that goes that way, and that goes that way, and that goes that way. Which you can see in this Mendel Square. You're going to get one yellow one and one dark one. And one yellow one and a dark one. Another yellow one, another dark one. And another yellow one, another dark one. So with this kind of a deal, with a father that's black, you're going to get all black puppies. And if you look through our bloodlines, you can see we have an awful lot of black. The black is dominant to everything else. So let's start varying this and see how this works if we get this all smeared up again. If we start with Dad being one of those, he is black looking, but he has this hidden gene of that color. And let's do the same thing with Mother. She looks black, but we're not too sure of whether she has this for another parent or not. So if you have this combination, then from here to here you get pink to pink, you get one of those puppies. And down here at the bottom, you get one of those puppies. And then over here, you get one of these puppies, yellow and yellow. And here, you get, because of that pink and this yellow, you get this combination. So, when you're breeding, these are two dogs that look like they're black, but they had a jumbled up looking, they had one of these harlequin puppies. Then you know that they were not pure black, that they had a recessive gene. And this would be the jumbled gene, if you will. If we started with, it's tough to get these harlequins. Even if you had the mother pure harlequin, still half your litter is going to be influenced by the black father. One of those, and one of those, one of those. And this one is pink, and this one is yellow, so we got that. And then this one is yellow and yellow. Get you that. And then this one is yellow and yellow over there. We've run out of yellow pieces of paper, have we? No, we didn't. That one and that one. So if you breed a harlequin dog, spotted, to a dog that looks black, but one of whose parents was harlequin, you get more harlequins, but you're still going to get the black. It's still going to come. If they look black, you're going to get black puppies somewhere along the line. It's very unusual not to have that black show up, and that's what's happening. Anybody have any questions? I don't know. We want to put on that thing to see whether there's any questions. Because in real life, the combinations get to be very complicated. And that, by the way, if you're going to look it up online, that's called a Mendel Square. That's how a guy named Mendel tried to describe it to everybody. Okay. Okay, so we have any questions? This is amazing, great illustration. Well, I'm certainly glad you're pleased. Now, if the kids are, if we're away from the kids watching, it gets even more confusing because they get into whether the patches on the dog are torn like these are, or whether the edges are smooth like sizzles, and they can begin to carry that off into all of these colors too. And I think as far as Dawn's group is concerned, you probably ought to look up Mendel Square and see what it says. If it says that kind of thing anymore. Maybe, I don't know, maybe they have something new out that I don't know about. But because I'd say that one goes there. I think that's all we want to talk about. We don't want to talk about the gender. We don't want to talk about the gender. Do we want to talk about the gender? No. Everybody has two genes. The genes. Every part of your body has two genes, except when you start to make eggs and sperm, and then they split into that kind of a deal. Okay, I better quit. Okay, bye. Shutting off. certainly glad. There's one of our board of directors that watched the siphoning thing and said, I have saved her life because she'd been trying to empty her fishbowl. And she had no idea how you could fill a siphon hose by sinking the whole thing down and getting all the bubbles out of it. And then you didn't have to put the thing in your mouth to get it started. So all this craziness has certainly helped one person. Bye.